Okay, hello everyone. And today I will talk about Cloud Swift with AWS. Before we start, how many of you write any Swift code? Okay, that's good. How many of you write server-side Swift, like not iOS version? Oh, okay, I got an introduction to both Lambda and server-side Swift, so I know that I need to talk about both of them. Thank you very much. So, as I said, I will talk about AWS Lambda, about server-side Swift, and how to make them work together. And on the end, we will get a small demo to prove that I know what I'm talking about. So, what is AWS Lambda? So probably now some of you got a picture like this. There is cloud, there is Lambda, and probably maybe a little bit more, but let's go in a few steps. So Lambda is a function. So it takes some input and returns output. So it's basically function. It can be triggered by different events, and these events can be everything on AWS infrastructure, from S3 to databases and so on and so on. So it's a lot of different events you can plug in. It can generate artifacts, so you can execute Lambda and the result can be saved to S3 or database. It can call other functions, so you can create quite complex stuff by combining functions together. And at the moment it supports many programming languages like Java, Node.js, Python, but not Swift. So maybe now image of AWS Lambda is like this. So it's some function that can connect to some other function or some other infrastructure thing in AWS. So why to use AWS Lambda? Like before we start learning about something, it's always good to question, is it worth or maybe it's just wasting of time. So AWS infrastructure is a pretty huge thing, and it has a lot of stuff to build your infrastructure in the company. So it has IoT support, AI, file storages, databases, message services, network components, so we can isolate secure private networks, and you can deploy servers. So everything in the cloud. And having stuff in the cloud make it easier to share with others. So if you write some awesome piece of Swift, it's better to put it in the cloud so you can show it to your friends. And with the right tools, maintenance and development is easy. So I always got problem that I got some super idea, and when I write some code and I leave it somewhere on the computer and I don't remember where it was after a few months. So if you put it in the cloud, maybe you will forget, but your friends maybe will remember. So that's always a good reason as well. And there is many utils that helps you to work with AWS infrastructures, and most of the languages, including Swift this time, supports AWS API. So if you have some Lambda already running in the cloud, you can run it from the iOS application through Swift API. So that's pretty cool. And it's already a huge advantage, even if you don't want to bother with this whole server-side Swift. And I want to talk a little bit about serverless. This is a tool I'm using to manage my AWS infrastructure. So it makes everything much easier, and you can commit the state of the infrastructure into the Git repository, for example. So next time you screwed up something, you can just reset to the previous commit, and hopefully everything will work again. Okay, so let's start from serverless. For most of you probably it's a new thing, so to install it is you need npm on your machine. And it's basically npm install -g serverless. Then, to create Lambda function, you need to create the code for the handler. In this case, I will create it in the JavaScript for now. So you basically open some handler.js and you put JavaScript code there. Then you open serverless.yam and you will put basic configuration. So the Lambda will know which part of code to run for you. And then you can do serverless deploy and it will make everything happening in the cloud. So this is example handler in JavaScript. So it's not crazy stuff. Even if we mostly write Swift, it's not hard to understand this code. So in this case, Lambda always return a result hello world. And this is a really simple serverless YAML config file. And we tell here to run handler.js file with hello function. And in this example, you can plug it to the event that can be like cron fired every 1 minute. So this is already pretty awesome. Other kind of event can be HTTP event, so you can hit your Lambda using curl, or you can put URL in the browser and you will get result there. And there is many others. I was trying, for example, IoT endpoint that you can subscribe on some topic on MQTT server, and each time when you will receive message, it will trigger Lambda. So there is a lot of possibilities. And yeah, why to use Swift? I don't need to ask this question here, I think, but Swift is awesome language. Client and backend in the same language make it easier to develop, isn't it? I do backend Ruby on Rails job, and sometimes we got some other project in iOS. So even if I'm fluent in both of languages, it always takes a little bit overhead to switch between them. So it's not about the language only, it's about the libraries you are using. So if you spend 3 days in Swift and you go back to Rails, it's always a little bit like more problems and stuff. So having everything in one language makes stuff easier. And a lot of existing libraries and frameworks is in Swift. And not only iOS Swift version, but it's pretty awesome community in the server-side Swift. And a lot of frameworks like Vapor. Who is using Vapor maybe here? Yeah, some people will know what I'm talking about. So even if you are not using these frameworks directly, development on this framework is causing a lot of libraries to come up to existence. So it's worth to watch the space. And other thing about Swift, it's super easy to wrap existing C libraries. So if you connect these two things, that you got some Linux server in the cloud that already have some C libraries, and you can make much easier to using these C libraries by wrapping the code in Swift. It's a pretty powerful tool. And Swift Power Manager is great. So that's a tool that helps you manage all dependencies for your program. And it helps integrate with what I mentioned, C code as well. So if someone haven't looked yet, there is a really nice presentation about Swift Package Manager. You just need to Google it for it and pretty awesome tool. So I will give you a little bit introduction to the Swift Package Manager. So when you start new project, is basically creating a new folder. You get into that folder and you run Swift package init with type executable. So this is basic setup. So if you do these 3 lines, you can run Swift build, and you will get hello world example application. So later on, to edit the source code, you just change one file and you can change how it behaves. So it's pretty easy, and each time you develop something more complex, it's always good to have help from your Xcode. So you don't need to edit this code like on the server using VI. You can create Xcode project. You can automatically generate this file, so you should just commit it. And if you generate it, you can open Xcode like usual iOS project. So it helps out if you've got some like debugging problems and stuff. And the most interesting thing, how to get the Swift code to run on Lambda. So first thing you need to find some Linux box. So Lambda function is underneath. No one probably wants to know about the details, but it's based on the Linux box. So to prepare the binaries for it, you need some Docker container, virtual machine, easy to install, or standalone machine that is Linux. You need to install the Swift. Then you can compile Swift code, and you need to create wrapper to the binary code in existing supported language. So I will show JavaScript example for example. And then we can upload prepared code using API or serverless. So my workflow looks like this. I'm using git push when my code is compiled, when it's finding for the dependencies that are required for the binary to run. It will be completely different machine, so everything what is installed on your machine needs to be like gathered together and packaged in one zip file, and then we can upload it to the Lambda. And smooth deploy is pretty important. So I don't know how about you, but I'm using quite often just internet from my K-Tile or pocket Wi-Fi, and I would upload even like 30 megabytes each time I work on some Swift code. Probably I would end up without internet within like few days. So less code you send to the internet is better, and it makes everything more smooth and it makes everything easier. So that's the Git hook I'm using. So the way how I work, I do have Git repository on the EC2 instance, and the Git hook basically each time repository receives the push with new source code is running that deploy.sh script on the bottom. And before I showed the deploy script, I tried static linking, so this would reduce all the problems with the dependencies. You wouldn't have to look for the all libraries the binary needs to run. But I'm not too good in like static linking stuff and so on, so if someone got some experience, please share with me. I gave up on this solution. So next thing I tried to use AWS MI instance that is really close to what Lambda is. That helps to reduce problems with library version compatibilities. And unfortunately, I discovered that Swift is supported mostly on Ubuntu at the moment. So if you try to install Swift on other distribution, maybe you will be lucky when you install from source code. But when I tried to do it, I found out at some point that it produced a lot of like 32 gigabytes of different artifacts and stuff you need to compile. So probably it's better to stay with Ubuntu, and it makes life easier. So what worked for me, I used Ubuntu Linux EC2 instance and some magic sorcery to convince Lambda to run it for me, because it's a little bit different than standard Lambda Linux. So let's go back to deploy script that my Git hook is running for me. So there is Swift built with some magic options. Mostly in my example, I'm using Redis extension to connect from Lambda to the Redis. So I have to specify, like in C language, a little bit additional options, but otherwise it's just other script that helps me to find out all dependencies. And when we got all of this, we can just upload everything to Lambda. So upload is just uploading everything to the Lambda. A little bit around the options. So each time when we want to pass linker options to C level, we need to specify X linker options. And even if you got like many options, you need to always specify X linker and then some option, X linker, some option. So we cannot, maybe you can, but I don't know how to do it, like to pass many options in one call. Same thing for the C compiler options. You need to call first this XCC, and then you can pass standard C options. So this will teach linker where to find Redis library. And to find all dependencies, I'm using this script that is parsing the output of LDD command. If you run LDD command on Linux system or binary program, it will list you all the libraries that this binary require. So we just parse the output and we put everything in one place. And finally, this is the JavaScript wrapper. So we are able to run the Swift binary in the Lambda. And when I look at this code, I try to make it simple as possible, but it's still hard to read. Luckily, 1 week ago, AWS starts supporting Ruby language, and this makes stuff a little bit easier. So if we switch from JavaScript to Ruby, that's basically how you can run the binary. So basically, it's just this command that we run in the way we can pass input. So we can pass input event we receive in the Lambda directly to the Swift binary. And on the end, we will just output a result of this command. So we can see the result as a result of the Lambda function. And that's the Swift code I will try to compile. So interesting thing is how we will receive the input from outside. So it's basically, in the command line, it will be just piping output from our command to the Swift code. So when we test it in the command line on Mac, we can just pipe code directly to this binary. And that's how we read it inside the Swift code. And the other stuff is just using Swifty.json. Yes, we can use Swifty.json in server-side Swift. That's pretty awesome. And we will just parse a little bit event and print it back. So that's all the code. Okay, so I think it's demo time. So at first, let me try if everything still works as it is now without any changes. So I do have some Lambda function that is hooked into HTTP gateway. So each time I use the care command, it should hit the Lambda, and you could realize that it's a little bit delayed. So it took maybe like 10 seconds, first invocation. Next time I run it, it's much faster already. So I measure this invocation of the carer takes a little bit time, but if you keep some process running and just call the Lambda function, you will get something around 100 milliseconds. So it's not too bad, even if we run external binary within the Lambda function. And because it's plugged into HTTP request, and we can run it in the browser now. I got the same URL in the browser, and it tells me my JSON is formatted incorrectly. If you see what happens here on the top of the file, you see that it's some garbage, right? So I screwed up some code. Let's fix it. Yeah, I will not use Atom. Probably it's better to use something that's more helpful. So make sure that we generate the Xcode project. Then we will get a project we can open in Xcode. And then in the sources, command foo is the name of my program. There is main Swift file. We can edit. And we will see that I'm using my, sorry for that, and that I'm using my C wrapper to call Redis, and I just print out the output on the screen. So let's make it a little bit better so we don't need to like break the JSON format. Let's call it basically value, and let's do exactly what print was inside. So we just write result to the value. Compiler is happy, right? Compiler is built on the C extension, so I hope it's fine. That's the change we did. And we are pushing code. I'm so nervous that I'm not completely sure I made the code correctly, but looks like it's happy. At least compiling it. Let's try it again. And look it a bit better, right? So let's try it in the browser. Yay, we got correct JSON. So this Lambda is not just a really simple Lambda with like hello code. What this Lambda got is connection to the virtual network together with my EC2 instance. And I do have Redis server running on my EC2 instance. So if I go to my server now, and I tell Redis to set, hopefully I got the command somewhere. Let's set magic number to, I need some number. 42. Okay, 42. And let's go to the browser and call the function again. And the magic number is? So on the end of the slides, I put all the materials I was using, and hopefully it will be helpful for discovering server-side Swift and Lambda. Thank you for attention.
We've got time for maybe a couple questions.
Yes?
If you put that last slide up while you answer questions.
Okay. So any questions? I haven't, and I do it on purpose.
Okay.
Basically, I don't have enough time. I realized I played with Google like a really long time ago. Like it was, I even don't remember what was the name because they changed a lot of stuff. So I realized at some point that like Google, Microsoft, Amazon, they basically do the same thing using different APIs, different names and stuff. So I decided to follow only one. So if I need to migrate to some other technology, I think it will be pretty straightforward to just find out what is what. And that's basically my strategy. So. Any other questions?
I was kind of wondering about the Lambda API that you mentioned. So does this let you kind of call methods directly and like you don't have to use an endpoint, or is it still just kind of like how much does it abstract the methods you can call on the server side? Like, can you pass in like variables, for example, and then you get like a struct back, or is it like you're still parsing JSON?
Okay, so abstraction is you got advantage of all AWS stuff like credentials, authentication, for example. So So you can set up credentials in your iOS app. And when you call API, of course you can pass the params. So it will invoke function for you, and result depends how you will return it. So if you choose to return JSON from Lambda, you will have to parse JSON. So it will basically give you what you return in Lambda. And, but it's worth to play with. So I did play with. It makes kind of like some part of code separating from your app, so you don't need to release new version of the app if only thing you change is basically server code. So
Okay.
it's pretty nice. And you cannot use, unfortunately, the same libraries on the server-side Swift, like iOS Swift, but there is a server-side Swift library that lets you do the same stuff. So you can do both. So you can call Lambda function from server-side, and you can call it from the iOS side.
Okay.
Any other questions?
So it looks like being able to statically link the framework to the actual binary makes running it a lot easier, but were the issues you're encountering, like, were they seen due to the Swift package manager or just like Swift on Linux? Or like, can you tell me
Okay, so
about what?
yeah, I had a little bit interesting issues. So as you realized, I prepared demo with the SQL. And the decision I made, it was because I do have Nano instance on AWS. So when I added, using package manager, many other dependencies, like for example libraries to call Lambda function on AWS, and during compiling, it requires a lot of memory. So my instance got only 500 megabytes. So it was basically crashing because of the lack memory.
Okay.
So I fall back what I can do with my current setup.
Okay.
But so that's one of the problems. Other problems. Yeah, the main thing is the binary compatibility. So on the Lambda you will get a little bit different C versions and stuff. So basically you need to find out all libraries you are using on your machine and package everything together. Plus this little trick I showed in the slides. Otherwise, it works pretty well.
Okay.
So I don't use it in production. I use it mostly for fun. But it makes it much easier to, for example, call some code from my Raspberry Pi. When I got a really tiny environment, I don't want to write everything in C. So I can have just one function that knows how to call the Lambda, and then I can write all the parts in Swift.
So it doesn't seem like you're able to, for example, like cross-compile on Mac OS to Linux. And maybe if you wanted to, you have to like use Docker for Linux.
Docker for sure. For example, one of the links about one of these links is described running Swift code in the Lambda.
Okay.
And the author is using Docker container.
Okay.
So I just demonstrated it on EC2 because it's, I don't want to keep Docker on my machine because of what I mentioned with transferring a lot of megabytes. But it will work for sure. So it's, you can do a lot. You can make it cross-compile. So I did play at some point with cross-compiling mRuby for iOS Swift application. So you can do Ruby export a lot. But the whole point is to make everything as easy as possible. Otherwise, you will make it once and then after 2 months you will forget how it works. So that's my recommended way. Okay, thank you very much.